As you begin to settle into the stillness of evening, you may notice the way your breath gently moves in and out, the rise and fall of your chest, the quiet rustle of fabric, perhaps a flicker of light from beyond the curtain. These are not distractions. They are signals, subtle messengers, whispered through the elaborate system of senses that your body has relied upon since birth. Human perception begins not with the conscious mind, but with the body. Long before thoughts take shape or language is formed, the senses are already at work, detecting, interpreting, and translating the world into meaning. Each flutter of wind, each taste of sweetness, each soft vibration beneath your skin carries information, and all of it is absorbed quietly by specialized structures woven throughout your body's living tissue. The human sensory system is not merely a collection of isolated parts. Rather, it is a continuous, flowing network and elegant dance between the outer world and the inner self. Through it, your body gathers impressions and offers them to your brain, where they are quietly assembled into the story of your experience. The ancient tradition of listing the five senses, sight, hearing, taste, touch, and smell still, holds a kind of comforting symmetry. These are, after all, the most familiar. But modern science reveals a deeper complexity. In truth, your body perceives far more than five distinct categories of sensation. There are senses that inform you of the temperature of the room, even without your touching anything at all. There are senses that tell you where your limbs are, even in darkness. There are senses that detect the stretch of your lungs, the acidity of your blood, the fullness of your stomach. These are the quiet, often unnoticed guardians of your balance, safety, and comfort. Together they form what researchers sometimes call the extended senses, or interoception, the sensing of your own internal landscape. These internal senses operate softly, often beneath conscious awareness, yet they are always working, adjusting, informing, and regulating. Consider your eyes, for instance. Even as you drift towards sleep, the retina continues to absorb light, measuring its intensity and color, sending signals to your brain, not only for vision, but also for regulating circadian rhythm, the internal clock that governs sleep and wake cycles. The sense of sight is not just about seeing. It is also about rhythm, timing, and balance. Or think of the skin, stretching over the surface of your body like a quiet observer. It contains thousands upon thousands of specialized nerve endings. These receptors are tuned not only to pressure and texture, but also to vibration, temperature, and pain. Some respond to the lightest feather touch, others to the dull warning of discomfort. Yet all of them feed into your understanding of where you are in the world and how safe or soothing that world might be. Even the sounds around you, distant traffic, a soft fan, the low murmur of your own breath are gently registered by the inner workings of the ear. Vibrations pass through the air, through bone, through fluid, until they are translated into patterns of neural activity, and the brain listens patiently, assigning meaning or allowing the sound to simply pass through without demand. Smell and taste, too, are part of this intimate dialogue. Through tiny chemical interactions, the brain builds entire experiences: a hint of vanilla, a trace of smoke, the first crisp bite of an apple. These senses connect directly to regions of the brain involved in memory and emotion, which is why a single scent can transport you instantly to another time or place. But none of these senses works alone. Your perception is built from their collaboration. When you sip a warm drink, you are not only tasting it, is also the feel of the cup in your hand, the scent rising with the steam, the warmth as it travels down your throat. These inputs blend seamlessly, and the brain weaves them into a unified impressions, oft familiar, real. This is the miracle of human sensation. Not just that you see or hear or taste, but that these signals arrive continuously, gently, and with astonishing precision, and that your body, without any conscious instruction, receives them all, interprets, filters, integrates, and responds. Even now, as you listen to these words, your senses are active, but not intrusive. Perhaps you feel the texture of your blanket, the shifting weight of your limbs, the temperature of the air against your skin. Perhaps a single sound distant and dim drifts through the background. And still, your body remains in calm alertness, always sensing, always adapting, without ever needing to explain itself. In essence, the senses are not just tools for gathering external data. They are part of the fabric of who you are. They guide your movements, shape your thoughts, and allow you to feel connected to others, to nature, to the rhythm of life itself. As this journey into the senses begins, let us take our time. There is no need to rush or to learn with urgency. Instead, we move gently from one sense to the next, observing, noticing, understanding, softly, and in doing so, we begin to appreciate the quiet brilliance of the human body, not only for what it does, but for how quietly, how patiently it does it. Let the breath slow just a little more. Let the body rest into stillness. The world of sensation is already here, and you are already listening. Part 2. What is a sense? A soft definition. When we speak of the senses, it is easy to picture 5 familiar gateways to the world sight: hearing, smell, taste, and touch. These are the senses most often named in conversation, in poetry, in stories. They are taught in early childhood, often represented by drawings of eyes, ears, noses, tongues, and hands. But beneath this comforting simplicity lies a subtler, more intricate truth. A sense, in its essence, is the body's ability to detect and respond to a particular kind of stimulus. These stimuli can arise from the world outside: the warmth of sunlight on the skin, the fragrance of rain, the gentle rustle of leaves. Or they can come from within your heartbeat, the fullness of your lungs, the stretch and release of your muscles. The classical 5 are not incorrect. They are simply incomplete. Most neuroscientists now agree that humans possess many more than 5 senses. Some suggest 12, others suggest as many as 20. The number depends not on invention, but on definition, on how we choose to distinguish one type of perception from another. Let us begin softly by organizing the senses into broad families. The first are the interoceptive senses, those that allow us to perceive the external environment. Sight, hearing, smell, taste, and touch fall into this group. These senses connect us to the outer world, and their function is to gather information about things near and far, soft or sharp, bright or dim, fragrant or bland. Then there are the interoceptive senses, those that help the body monitor its own internal state. These are quieter, subtler, and often operate beneath the surface of awareness. They include the sense of hunger, thirst, the need to breathe, or the subtle pressure of a full bladder. They allow you to feel tired or alert, calm or agitated, and they gently steer you toward balance. Finally, there are the proprioceptive and vestibular sensestual systems, often overlooked but vital to every moment of movement. Proprioception is the sense of body position. It tells you where your arms and legs are, even with your eyes closed. It informs you of how much pressure you're applying, or whether your hand is open or clenched. The vestibular sense, located deep within the inner ear, provides your sense of balance, orientation, and motion. It keeps you upright when you walk and lets you know which way is up, even in darkness. These categories, though useful, are not rigid. The body's sensory systems do not operate in isolation. They blend, overlap, and collaborate in quiet harmony. A sense of taste, for example, is shaped not only by the taste buds on your tongue, but also by smell, temperature, and even texture. This interweaving of input creates a richer, more nuanced experience than any single sense could provide on its own. Each sensory modality begins with specialized receptor-stimuli biological structures, finely tuned to detect specific types of input. Some respond to light, others to vibration, some to chemical signals, others to temperature, pressure, or stretch. These receptors are scattered throughout the body within the skin, the muscles, the organs, and the deepest tissue sand. They are always quietly at work. When a receptor is stimulated, it converts the physical signal into an electrical impulse. This process, called transduction, is the beginning of perception. The impulse travels along nerve pathways to the brain, where it is processed, interpreted, and given meaning. You do not experience the raw signal itself. Instead, you experience its translation, a color, a sound, a sensation. This journey from stimulus to experience occurs in fractions of a second. It is fast, yet effortless. Most of the time, it goes unnoticed. But it is through this hidden process that you are able to move through the world with grassetto, adjust your stride on uneven ground, to reach for a glass without missing, to navigate conversation, space, and silence. Not all senses involve conscious awareness. Many function automatically, working behind the scenes to preserve your internal equilibrium, a state known as homeostasis. For instance, you may not notice when your blood sugar falls slightly, but your body does. Signals are sent, hormones are released, hunger slowly rises. These feedback systems are senses, too just as real, just as precise, but tuned to inner harmony rather than external details. There is also a beautiful fluidity in how the senses evolve and adapt. When one sense is diminished, say, the loss of sight, others often become more sensitive. The brain reallocates attention, adjusting how space and time are perceived. This plasticity is one of the nervous system's quiet wonders, a demonstration of how deeply the senses are integrated into your being. And yet, for all their complexity, the senses remain deeply personal. The taste of a fruit, the sound of a distant bell, the feel of cool water on the skin, these are universal experiences. Yet no two people experience them in exactly the same way. Genetics, past experiences, even mood, all shape the way sensory input is interpreted. Your world is not a mirror of what is out there, but a unique composition woven gently from the signals your body receives. As we move forward into the individual sensesite, hearing, smell, taste, touch, and beyond, we will explore not only how they work, but also how they interlace. We will linger on the fine details, but always with softness, always with the awareness that the body, in its quiet work, offers not only survival, but beauty, an uninterrupted stream of experience, waiting patiently to be noticed. And so, the senses are not just mechanisms. They are invitations to feel, to understand, to be present. Each one opens a window, not only onto the world, but into yourself. Let the breath remain gentle. Let the body continue to rest. There is much more to explore, and we will take it slowly. Part 3. Vision. The eye's gentle interpretation of light. Among all the senses, vision often feels the most immediate. It is our primary way of gathering information about the world around us. And yet, for all its clarity and detail, vision begins with something intangible: light. Photons, the smallest packets of energy, travel across space, reflected from objects, bent through atmosphere, filtered through leaves, before they ever reach the eye. The human eye receives this light with quiet sophistication. Nestled within the protective orbit of the skull, each eye is a smooth, rounded organ, about an inch in diameter. It sits behind the eyelids, those gentle shields of skin and muscle, and is wrapped in layers of moisture, muscle, and tissue that work tirelessly to keep it focused and safe. The outermost layer of the eye is the scleratha, white, fibrous shell that maintains the eye's shape. At the very front of the sclera lies the cornea, a clear, curved window that allows light to enter. Unlike glass, the cornea is alive, composed of thin layers of transparent cells, and nourished by tears and fluid from within. Just behind the cornea is a shallow chamber filled with aqueous humor, a clear fluid that provides nutrients and gently maintains internal pressure. Then comes the iris, the colored ring that gives each person their unique gaze. The iris is more than ornamental. It functions like a diaphragm, adjusting the size of the pupil, the central opening that controls how much light is allowed to pass through. In bright sunlight, the pupil contracts, narrowing to a fine circle. In darkness, it expands, opening wide to drink in as much light as possible. This adjustment is known as the pupillary light reflex, and it happens automatically in response to the ambient environment. Once past the pupil, light travels through the lens, a flexible, transparent structure that bends and focuses the incoming rays. The lens is held in place by fine ligaments attached to a ring of muscle. This muscle subtly alters the lens's shape, allowing the eye to focus on objects both near and far. This process, called accommodation, is typically so seamless that you only notice it when it falters, such as when trying to read small print in dim light. Beyond the lens lies the largest chamber of the eye, filled with a jelly-like substance known as vitreous humor. This fluid helps maintain the spherical shape of the eye and provides a clear path for light to reach the retina, the innermost and most sensitive layer of the eye. The retina is where vision truly begins. A thin sheet of nervous tissue, it lines the back of the eye and contains millions of specialized cells known as photoreceptors. These photoreceptors come in two primary forms: rods and cones. Rods are responsible for vision in low light. They do not detect color, but they are exquisitely sensitive to shades of gray, black, and white. Most rods are concentrated around the periphery of the retina, which is why your peripheral vision often perceives movement better in dim settings. Cones, by contrast, function best in bright light and are responsible for color perception. They are densely packed in the fovea, a small, central region of the retina that allows for the sharpest vision. There are 3 types of cones, each sensitive to different wavelengths of light roughly corresponding to red, green, and blue. From these 3 inputs, the brain constructs the full, rich spectrum of color you perceive each day. When light strikes these photoreceptors, it triggers a cascade of chemical changes that generate tiny electrical signals. These signals travel through layers of retinal neurons, eventually converging on the optic nerve. From here, they are sent along delicate nerve fibers, through the optic chiasm at the base of the brain, and into the visual cortex located at the back of the head. Remarkably, what the retina receives is not a perfect image, but a reversed, upside-down projection. It is the brain that corrects this inversion, flipping and interpreting the data, filling in blind spots, blending images from both eyes to create a single, coherent view. The world you see is not what lands on your eyes, but what your mind reassembles in stillness and light. And yet, the visual system is not concerned only with clarity. It also interprets motion, depth, shape, pattern, and brightness. It senses contrast and tracks subtle changes. It builds familiarity, recognizes faces, and responds to sudden shifts in the environment. Even in darkness, when the rods dominate and colors fade, the eyes continue to scan gently, adjusting to the absence of light. This adaptation, known as dark adaptation, takes time, sometimes up to 30 minutes, and reflects the body's patient recalibration to the changing world. The muscles around the eye, though rarely noticed, also play a quiet role in vision. 6 tiny extraocular muscles allow each eye to move in nearly every direction, coordinating seamlessly to track objects or shift focus. These muscles are so precise that even the smallest movements called saccades are executed in fractions of a second. As with many bodily functions, vision is not just about the organ itself. It is shaped by attention, memory, and emotion. A familiar face may seem more vivid than a stranger's. A sunset more beautiful when shared. The eyes receive light, but the mind creates meaning. For those who lose or lack sight, other senses often become more finely tuned. The brain repurposes areas once devoted to visual processing, enhancing touch, sound, or spatial awareness. This neuroplasticity is one of the quiet marvels of the sensory system, a testament to the body's resilience and adaptability. And so, the sense of vision is not merely mechanical. It is immersive. It invites wonder. It gathers not only shapes and colors, but also presence, letting in the shifting light of morning, the soft blur of twilight, the silent glint of starlight on a still night. As your eyes close and rest now, they continue to serve you. Behind the lids, the system idles softly, waiting for light to return. Even in sleep, tiny movements continue. Dreams may arise. Imagined landscapes form, and the visual system, with all its quiet complexity, carries you through a world seen not with eyes, but from within. Let the lids grow heavier, let the mind quiet. The light will still be there when you wake. Part 4. Hearing, the quiet machinery of sound. Sound begins not with words or music, but with vibration. A movement in the iris leaf trembling, a footstep on wood, a breeze brushing against a window pane sets off tiny ripples through the atmosphere. These waves of energy travel invisibly, silently, until they reach the body's dedicated receiver, the ear. The human ear, though small in size, is a masterful acoustic instrument. Its purpose is both simple and profound, to detect vibration and translate it into meaning. As with sight, the process is nearly instantaneous and mostly unconscious. You do not try to hear, you simply do. And yet, within this simplicity lies a marvel of gentle engineering. The outermost part of the ear is the pinna, the soft fold of cartilage that cups outward from the head. Though often overlooked, the pinna plays a vital role. Its unique shape helps capture sound waves and funnel them inward. It also aids in localizing sound, giving subtle cues about direction and distance. From the pinna, sound enters the auditory canal, a slender passage lined with fine hairs and wax-producing glands. This canal gently amplifies certain frequencies while protecting the more delicate structures deeper within. At the end of the canal lies the tympanic membrane, more commonly known as the eardrum. This thin, flexible sheet of tissue vibrates in response to sound waves, much like the surface of a drum. Even the faintest whisper causes it to move. These vibrations are then passed along to the middle ear, where the smallest bones in the human body await their turn. The middle ear contains 3 tiny bones, the malleus, incus, and stapes, collectively called the ossicles. Their names, drawn from Latin, mean hammer, anvil, and stirrup. Together they form a delicate chain that bridges the gap between the eardrum and the inner ear. When the eardrum moves, it sets the malleus in motion. The malleus nudges the incus, which in turn presses the stapes. This mechanical relay amplifies the vibrations, focusing their energy toward a small, oval-shaped window leading into the cochlea, the inner ear's spiral sanctuary. The cochlea is a coiled, fluid-filled structure resembling a snail's shell. Within it lie microscopic hair cells, thousands upon thousands of them lined along the basilar membrane. These hair cells are not hairs in the usual sense, but specialized sensory receptors topped with fine projections called stereocilia. As vibrations enter the cochlea, they create ripples in the fluid, These waves move the basilar membrane, causing the stereocilia to bend. This bending triggers a cascade of electrical signals, converting mechanical energy into neural impulses. Each hair cell is tuned to a specific frequency, like keys on a piano, allowing the cochlea to separate and identify a broad spectrum of sound. These electrical impulses travel along the auditory nerve, also known as the cochlear nerve through the brain stem, and ultimately reach the auditory cortex in the brain's temporal lobe. Here, the signals are assembled, interpreted, and recognized. A friend's voice, the hum of a refrigerator, the patter of rain against the window. Hearing, then, is not just about detecting sound, it is about organizing it. The brain groups similar sounds, filters out background noise, and assigns emotional or practical meaning. It knows the difference between footsteps that approach and those that fade, between a lullaby and a siren, between silence and stillness. And just as with vision, the hearing system is exquisitely adaptable. Through a process called auditory masking, your brain can tune out certain sounds to focus on others. This is how you can follow a conversation in a busy room or hear your name whispered amid distant chatter. The inner ear also contains the vestibular system, which governs balance, but we will visit that in a later part. For now, we remain with sound. Remarkably, your ears are always on, even in sleep. While your conscious mind rests, the auditory system remains quietly alert, monitoring for meaningful signals. A baby's cry, a knock at the door, the sudden clatter of something falling. The brain decides which sounds to acknowledge and which to ignore. The emotional resonance of sound also deserves a moment of reflection. Certain tones can calm the nervous system, like the slow rhythm of ocean waves or the gentle rustling of trees. Others may stir memories, evoke sadness, or offer comfort. Music, with its structured complexity, has the unique power to bypass language entirely, reaching deep into emotion, rhythm, and memory. Even silence is part of hearing. The absence of sound is not a void but a space, a moment of rest between vibrations, a pause that allows the body and mind to settle. In fact, silence itself can be soothing, a kind of auditory stillness that mirrors the calm of breath and the steadiness of heartbeat. Some individuals experience partial or total hearing loss. In such cases, other senses often rise in prominence. Visual cues, vibrations, and even the feel of air movement become more pronounced. The brain compensates, reshaping its sensory map to make use of whatever input remains. And in this way, hearing, like all the senses, is both personal and adaptable. It reflects not only the physical world, but the internal landscape as well. What you notice, what you focus on, and what you remember are all shaped by attention, experience, and need. So now, as you lie in stillness, perhaps you notice the gentle hush of the space around you, the hum of a distant appliance, the softened contours of evening, or perhaps all you hear is the soft rhythm of your breath. That too is a kind of music. Let your ears rest, knowing they do not need to search. The world of sound, with all its quiet detail, will still be there when you return to it. Part 5. Smell, a delicate dance of molecules and memory. Of all the senses, smell may be the most quietly intimate. It drifts in on unseen currents, carried by the air, unannounced and often uninvited. And yet, it slips past logic and enters memory. A scent can awaken a season, summon a forgotten room, or bring the presence of someone long gone. Unlike vision or hearing, which often require focused attention, smell works gently in the background, shaping perception without demanding notice. This gentle sense begins in the upper portion of the nasal cavity, where a small patch of specialized tissue known as the olfactory epithelium resides. Here, nestled beneath a thin layer of mucus, are the olfactory receptor neuron cells designed specifically to detect airborne chemicals. As you inhale, molecules carried on the breeze dissolve into the mucus and bind to tiny receptor proteins on the surface of these neurons. Each receptor is tuned to recognize a specific structural feature of a molecule's shape, or sometimes its vibration. The moment a match is made, the neuron generates an electrical signal. This signal travels up through the olfactory nerve, the first of the 12 cranial nerves, and into the olfactory bulb, a small structure located just above the nasal cavity, at the base of the brain. From here, the signal is routed to various parts of the brain, including the amygdala and the hippocampus regions, deeply involved in emotion and memory. This unique arrangement is part of what makes smell so evocative. Unlike other senses, which first pass through the thalamus for filtering, smell enters the emotional centers of the brain directly, unfiltered, raw, and real. The olfactory system is astonishing in its sensitivity. Humans can detect thousands of distinct odors, even in incredibly low concentrations. And though we often think of smell as less acute than sight or sound, it remains profoundly influential. It can alert you to danger, like smoke or spoiled food, but it can also soothe, drawing you into quiet comfort of familiar perfume, the scent of earth after rain, the trace of pine in a forest breeze. Each person experiences scent uniquely. This is partly genetic. Some people are unable to smell certain compounds entirely, a condition known as specific anosmia. A well-known example involves androstenone, a compound found in human sweat. Some individuals perceive it as sweet and floral, others as unpleasantly musky, and some do not perceive it at all. This variation in perception underscores an important truth. Smell is personal. Even the same scent can evoke different responses in different people, shaped by past experiences, cultural context, and emotional associations. The receptors responsible for smell are part of a family known as G-protein-coupled receptors. When triggered, they initiate a chain of intracellular events, leading to the opening of ion channels and the generation of an action potential. This is the language of the nervous system, an electrical whisper, traveling inward, toward recognition. Each olfactory receptor neuron expresses only one type of receptor, but their axons converge in organized clusters, known as glomeruli, within the olfactory bulb. Each glomerulus collects signals from neurons expressing the same receptor, sharpening the signal before it continues its journey into the brain. The olfactory neurons themselves are short-lived, typically lasting about 30 to 60 days, but the body quietly regenerates them, thanks to stem cells in the nasal lining. This continuous renewal makes the olfactory system one of the rare sites of adult neurogenesis, a fact that has inspired researchers studying brain repair and regeneration. Smell is also an integral part of flavor. Though we often think of taste and smell as separate, nearly 80 to 90% of what we perceive as flavor is olfactory. This is why food loses its richness when we have a cold, and why aromas are often described using flavor terms earthy, sweet, spicy, sour. The collaboration between taste and smell occurs primarily in the retronasal passage, where scent molecules from food travel from the mouth into the nasal cavity, especially during chewing and swallowing. In this way, the brain weaves together signals from the tongue and the nose into a unified impression of what we call flavor. Interestingly, the olfactory system does not require conscious inhalation to function. Even as you rest or breathe softly in sleep, odor molecules continue to reach the receptors. Some studies suggest that certain smells, such as lavender or rose can, subtly influence sleep quality, easing the transition into deeper stages of rest. In the animal kingdom, smell often plays a central role in communication. Pheromonous chemical signals released by one individual and detected by another convey information about territory, fertility, and emotional state. In some mammals, these signals are processed by a specialized structure called the vomeronasal organ. Whether or not humans retain a functional version of this organ remains debated, but subtle chemosensory communication may still occur in ways we do not fully understand. Smell, like other senses, changes with age. Receptor cells regenerate more slowly, and sensitivity declines. This natural loss, known as presbyosmia, can affect appetite, nutrition, and emotional well-being, especially in older adults. Still, the sense of smell often remains a powerful conduit for memory and emotional connection well into later life. And so, smell is not just a detection system, it is a bridge to memory, to emotion, to meaning. It offers no sharp images, no rhythmic vibration, only presence. The faint trail of jasmine in the dark, the smoky scent of autumn leaves, the clean, neutral quiet of fresh air. Now, as you breathe gently in and out, the world of scent flows with you. Perhaps the room holds a trace of something: fabric, wood, a hint of soap, or perhaps there is only the subtle, neutral clarity of air itself. Either way, the olfactory system remains alert, though you need not attend to it. You may let it drift. Let the breath soften. The world will continue to offer its quiet perfumes, carried invisibly on every breeze. Part 6. Taste. Chemoreception on the tongue and beyond. Taste, or gustation, is among the most intimate of the senses. It involves the body drawing in a substance, placing it on the tongue, pressing it softly against the roof of the mouth, and quietly assessing its nature. Sweet or bitter, nourishing or harmful, pleasurable or strange. It is a sense grounded in chemistry and steeped in experience. From the moment of birth, taste guides us towards safety. A newborn, when given milk, instinctively favors sweetness, a signal, deeply encoded, that what is consumed is rich in energy. Bitterness, by contrast, may provoke aversion. Many toxic plants produce bitter compounds, and the body, shaped by countless generations, has learned to recognize the warning. But taste is not solely a function of survival. It is also a source of comfort, of memory, of ritual, a favorite meal, a seasonal fruit, the first sip of warm tea on a cool morning. All of these are as much emotional experiences as they are sensory ones. The journey of taste begins on the surface of the tongue, though it does not end there. Scattered across the tongue are small, elevated structures called papillae. These come in 4 main varieties: fungiform, foliate, circumvallate, and filiform. Most papillae contain taste budstony, onion-shaped clusters of sensory cells, though the filiform papillae are an exception, serving a mechanical role without contributing to taste perception. Fungiform papillae, found primarily near the tip and sides of the tongue, appear as small, mushroom-shaped bumps. Foliate papillae form ridges along the rear sides. Circumvallate papillae, fewer in number but larger in size, create a subtle V shape toward the back of the tongue. Each papilla houses multiple taste budstony collections of cells that open onto the surface through a small pore, allowing saliva to wash chemicals from food into contact with the sensory receptors. Taste buds themselves contain gustatory receptor cells, each equipped with fine microvilli that extend into the taste pore. When a molecule interacts with these receptors, whether it be sugar, salt, acid, or another compound, it triggers a gentle cascade of events that results in the generation of a neural signal. This signal travels through one of 3 cranial nerves: the facial nerve, cranial nerve 7, which serves the front 2/3 of the tongue; the glossopharyngeal nerve, cranial nerve 9, which serves the back third; and the vagus nerve, cranial nerve X, which carries signals from the epiglottis and throat. These signals converge in the brainstem and ascend to the gustatory cortex, where the sensation of taste is consciously perceived. Along the way, Taste information is also shared with regions involved in emotion, motivation, and memory, helping to explain why food can evoke such strong feelings of nostalgia or comfort. Traditionally, 5 basic tastes are recognized: sweet, salty, sour, bitter, and umami. Sweetness signals the presence of sugar's energy-rich molecules necessary for life. Saltiness reflects the presence of sodium and other essential electrolytes. Sourness arises from acids, such as those found in citrus fruits or fermented foods. Bitterness, as mentioned, is often associated with potentially harmful substances. Umami, a Japanese word meaning delicious or savory, was the most recently recognized. It reflects the presence of amino acids, particularly glutamate, found in meats, broths, and aged cheeses. Each taste has its own receptors and pathways. Sweet, umami, and bitter tastes are detected through G-protein coupled receptors, similar to those in the olfactory system. Salt and sour, on the other hand, involve the direct movement of ions through channels in the cell membrane. Though the tongue mappa popular idea suggesting specific regions of the tongue for each taste is widely known, it is an oversimplification. All taste buds are capable of detecting all 5 tastes, though certain regions may show slight differences in sensitivity. Importantly, taste is rarely experienced in isolation. The perception of flavor arises from the integration of taste, smell, texture, temperature, and even sight. This collaboration is especially apparent when we have a cold. With the nose blocked, flavors seem dull or absent, even though the taste buds remain intact. The olfactory contribution is critical, particularly through retronasal olfaction, where scent molecules released from food during chewing travel up into the nasal passages from the back of the throat. The trigeminal nerve, another cranial nerve, contributes to this multisensory experience by detecting chemical irritants and temperature changes. This is what allows us to feel the heat of chili peppers, the cooling of mint, or the tingling of carbonation not as flavors, but as sensations. Taste is also subject to variation. Some individuals, known as supertasters, have a higher density of taste buds and perceive certain taste, especially bitterness, with greater intensity. This heightened sensitivity may influence food preferences and even dietary choices. Age, too, brings change. As we grow older, the number of functional taste buds declines, and sensitivity may diminish. This can alter appetite and enjoyment of food, particularly in the elderly. Cultural experience further shapes what we find appealing or off-putting. Foods that seem unusual to one person may be deeply comforting to another. What tastes acquired, what is celebrated, and what is avoided are all influenced by tradition, environment, and habit. Over time, preferences can shift, and once difficult tastes may become deeply appreciated. In essence, taste is not only about detection, but also about learning. It evolves with us. It tells us when to eat, what to avoid, and what to savor. It reminds us of who we are and where we come from, not through language, but through sensation. And so, the next time you taste something, even something simple, a piece of fruit, a sip of tea, a crumb of bread, know that the moment is composed not just of molecules and receptors, but of memory and context, a soft convergence of body, mind, and moment. As you rest now, the tongue too is at ease. No need to taste or decide. Let the mouth remain still. Let the senses quiet. And know that when you wake, the world of flavor will still be there, waiting patiently to be explored again. Part 7. Touch. The soft geometry of skin sensation. Touch is the first sense to develop in the human embryo. Before sight or sound, before the stirrings of taste or scent, the body feels. It senses contact. It registers pressure. It responds to warmth, to coolness, to motion. It is through touch that we first experience the world, not as an image or a sound, but as a presence. Touch is more than a single sensation. It is a family of perceptions woven together into the quiet landscape of the somatosensory system. It involves receptors embedded in the skin, muscles, joints, and even internal organs. It allows us to detect not only pressure and texture, but also vibration, temperature, pain, and the position of our own limbs. Of all the senses, touch is perhaps the most constant. Even as you lie still, the body is gently aware of the surface beneath it, the weight of the blanket, the quiet rhythm of breath expanding and settling. The skin, the body's largest organ, is the primary stage for the sense of touch. It stretches across your form like a soft, intelligent envelope, sensing what comes close and what moves away. The uppermost layer, the epidermis, provides a protective barrier. Beneath it, in the dermis, lie the specialized sensory structures that detect physical stimuli. Among these are mechanoreceptors, the cells responsible for detecting pressure, stretch, and movement. They come in different forms, each tuned to particular qualities of touch. Meissner's corpuscles, found near the surface of the skin, are sensitive to light touch and gentle fluttering movements. Merkel cells detect sustained pressure and texture, giving you the ability to feel the fine grain of wood or the weave of fabric. Pacinian corpuscles are deeper in the dermis and respond to rapid vibration like the buzz of a phone against the palm. Ruffini endings sense skin stretch and contribute to the awareness of joint position and movement. Each type of receptor has a unique shape and structure designed to capture particular types of mechanical change. As stimuli activate these receptors, they generate electrical impulses that travel along afferent nerve fibers, small highways that carry information inward toward the spinal cord and brain. This stream of information ascends through the spinal pathways, eventually reaching the primary somatosensory cortex, a specialized region of the brain located in the parietal lobe. This cortex contains a precise map of the body known as the sensory homunculus, where each part of the body is represented in proportion to its sensitivity, not its size. The lips, fingertips, and tongue occupy large areas of this map, reflecting their fine touch resolution, while the back or thigh takes up less space. Touch also conveys temperature through the use of thermoreceptors that respond to changes in surface warmth or coolness. These receptors are always active, constantly monitoring the skin's temperature and relaying information to help maintain homeostasis. Warm and cold receptors are distinct, each tuned to a specific range of temperatures. Unlike a thermometer, which simply measures, the body interprets. A cool breeze on warm skin may feel refreshing. The same breeze on chilled skin may feel sharp. A separate system monitors pain, the body's natural warning signal. Nociceptors, or pain receptors, detect harmful or potentially damaging stimuli, whether from heat, pressure, or chemical irritants. Though pain is often uncomfortable, its role is protective. It helps prevent injury, alerts us to illness, and encourages rest for healing. There are two main types of pain fibers. A. Delta fibers, which transmit sharp, quick sensations, and C fibers, which convey slower, duller aches. In addition to external sensation, the somatosensory system includes proprioception, the awareness of the body's position in space. Specialized receptors in the muscles, tendons, and joints detect stretch and tension, sending signals that inform the brain of posture and movement. This is how you can reach for an object without looking, or adjust your balance without conscious thought. This quiet feedback is what allows the body to move smoothly through the world, even in darkness. Touch is also a powerful emotional sense. Human connection often begins with a hand on the shoulder, a warm embrace, a resting palm. These forms of effective touch are mediated by a special class of slow-conducting nerve fibers known as C-tactile afferents, found primarily in the skin of the arms and back. These fibers respond not to pressure, but to slow, gentle strokes such as those received during a hug or caress. Their signals travel to brain areas involved in emotional processing, rather than the primary touch cortex, suggesting that touch is not only physical, but deeply social. And as with other senses, attention plays a role. You may not notice the weight of your clothing until it shifts. You may not be aware of the chair beneath you until you move. The brain filters much of this incoming information, allowing the background of sensation to fade unless something changes or requires action. The sense of touch is also adaptive. Over time, with repeated exposure, the body becomes less responsive to a constant stimulusa process known as sensory adaptation. This is why a watch on the wrist or glasses on the nose eventually fade from awareness. It is not that the skin stops detecting them, but that the brain chooses not to attend to them, preserving attention for what is new or changing. Touch in many ways anchors the self. It outlines the edges of the body. It reassures. It soothes. It keeps the mind grounded in the present moment. Even the smallest touch of breeze on the arm, the warmth of your own breath, the resting of hands at the side can be a gentle reminder. You are here. You are embodied. You are whole. And so now, as the night deepens and the body settles into stillness, let the sense of touch become a soft landscape. The support beneath you, the air around you, the temperature of your skin. Let it all become part of the quiet. Let it cradle you. There is no need to move, no need to reach. The body is already listening, and the sense of touch, so constant, so silent, continues to hold you in the gentlest awareness of all. Part 8. Balance. The vestibular system's silent stewardship. As you lie still and feel the gentle pull of gravity, you are engaging one of the body's most quiet and constant senses: balance. It does not arrive through light or sound, scent or flavor. Instead, it is a silent awareness of orientation, of being upright, of where your body rests in relation to the world beneath you. This sense, so rarely noticed in its harmony, is the work of the vestibular system. Housed deep within the inner ear, next to the cochlea that governs hearing, the vestibular system is a collection of delicate structures filled with fluid and lined with tiny sensory cells. Its role is to detect motion, both rotational and linear, and to keep the body and eyes coordinated during every turn, tilt, and shift in position. The core components of the vestibular system are the semicircular canals and the otolithic organs. Together, they form a quiet compass, one that functions even in complete darkness, gently informing the brain of every subtle movement. There are 3 semicircular canals, each positioned at a different angularly perpendicular to one another, forming an elegant 3-dimensional grid. These canals are filled with a clear fluid called endolymph, and at the base of each canal is a swelling known as the ampulla. Within the ampulla lies the crista ampullaris, a sensory structure containing hair cells covered by a gelatinous dome called the cupula. When the head rotates, the fluid inside the corresponding canal lags behind due to inertia. This causes the cupula to bend, which in turn bends the tiny hair cells beneath it. These deflections generate neural signals, informing the brain of the direction and speed of rotation. One canal detects nodding, as in yes. Another senses shaking the head side to side, as in no. And the third tracks tilting the head toward the shoulder. In contrast, the otolithic organs, the utricle and the saccula, detect linear acceleration and the position of the head relative to gravity. These organs contain a layer of hair cells embedded in a gelatinous sheet, topped with tiny crystals of calcium carbonate known as otoconia. The crystals add weight and inertia, so when the head tilts or moves forward, the otolithic membrane shifts. This causes the hair cells to bend, initiating a signal that reflects both movement and orientation. These signals travel along the vestibular nerve, joining the auditory nerve to form the vestibulocochlear nerve, the eighth cranial nerve. From there, they reach the vestibular nuclei in the brainstem and are distributed to areas responsible for eye movement, posture, balance, and spatial awareness. The vestibular system works hand in hand with vision and proprioception to maintain equilibrium. When you move your head, the vestibulo-ocular reflex allows your eyes to remain fixed on a target. This reflex is so fast and precise that your vision stays stable even while walking, turning, or riding in a vehicle. Without it, the world would seem to bounce and blur with every step. Balance is not just about standing or walking. It influences how you feel when lying down, when turning over in bed, or even when closing your eyes in a dark room. It governs your sense of up and down and helps the body orient itself in stillness. This is why lying flat with the eyes closed can feel so grounding. The vestibular system confirms that you are supported, that no adjustment is needed, and that rest is safe. Sometimes, the vestibular system sends signals that conflict with what the eyes see or what the body feels. This is the root of motion sickness, a mismatch between perceived motion and actual movement. For example, reading in a car may confuse the brain. The inner ear senses motion, but the eyes remain fixed on the page. The system attempts to resolve the contradiction, and this internal dissonance can lead to nausea or dizziness. In other cases, disturbances in the vestibular system itself can cause vertigo, a spinning sensation that arises without actual motion. This may occur due to inflammation, dislodged otoconia, as in benign paroxysmal positional vertigo, or disorders like Meniere's disease, which affects fluid balance in the inner ear. These episodes, though unsettling, are reminders of how central balance is to our quiet experience of the world. Despite its sensitivity, the vestibular system is robust. It continually adapts to new environments, whether learning to ride a bicycle, practicing yoga poses, or adjusting to the gentle sway of a boat. Over time, the brain recalibrates, forming new patterns of balance that become as seamless as walking. Even in sleep, the vestibular system remains partially active. While the eyes are closed and the body rests, it continues to detect movement and maintain a low-level readiness to respond. This is why, upon waking and sitting up, there is no delay, no confusion of direction. The system has remained quietly aware of your orientation all along. In infancy, balance must be learned. Newborns are born with the structures intact, but coordination takes time. Over the first months and years, the body learns how to integrate vestibular signals with vision and proprioception, gradually mastering the act of sitting, crawling, walking, and running. This process is one of the earliest collaborations between body and brain. In aging, the vestibular system may become less responsive. Tiny hair cells diminish in number, reflexes slow, balance becomes more fragile. Still, with practice, with awareness, and with the help of other senses, most individuals maintain stability well into later life. Simple movements, turning the head, closing the eyes, shifting weight from one foot to the other help the brain remain attuned to the quiet language of balance. And so, as you rest now, the vestibular system continues its quiet watch. It notes the stillness of your position, the symmetry of your breath, the calm of your surroundings. There is no effort required, no action to be taken, just a quiet assurance. You are steady, you are safe, the body knows where it is. Let yourself feel the gentle gravity that holds you. Let the world tilt into quiet, and trust that the system within you, the silent steward of motion and stillness, is gently listening, always ready, always calm. Part 9. Proprioception. Feeling where you are without looking. Close your eyes and lift your hand slowly into the air. You do not need to see it to know where it is. You do not need to hear it move or feel it touch anything. And yet, you know. The shape, the position, the angle of your wrist, the bend of your elbow, all of it is known without looking. This gentle, internal sense of bodily awareness is called proprioception, sometimes described as the sixth sense. Proprioception allows you to perceive the position and movement of your body in space. It is the reason you can walk in the dark, type on a keyboard without watching your fingers, or touch your nose with your eyes closed. It is not tied to a single organ, but instead arises from a rich network of sensors spread throughout the muscles, tendons, and joints. At its heart, proprioception is a mappa, quiet, continuous understanding of where your body is, how it is arranged, and how it is changing. This internal sense is essential for movement, for coordination, for balance, and for safety. Without it, the body would feel unanchored like a marionette without strings, unable to guide itself gracefully through the world. The sensory receptors that enable proprioception are known as mechanoreceptors, but they are different from those that govern light touch or pressure on the skin. Within the muscles lie specialized structures called muscle spindles. These tiny, spindle-shaped sensors detect changes in muscle length and the rate of stretch. When a muscle stretches, the spindle stretches too, generating signals that travel to the spinal cord and brain. Alongside the spindles, in the tendons that anchor muscles to bones, are Golgi tendon organs. These receptors monitor muscle tension, how much force is being applied during contraction. Together, muscle spindles and Golgi organs form a kind of dialogue between movement and resistance, letting the body know not only where a limb is, but also how it is moving and how much effort it is producing. Additional proprioceptive information comes from joint receptors, embedded in the connective tissues that surround movable joints. These receptors are activated when a joint is flexed, extended, or rotated, especially near the end of its natural range. Though they are less numerous than muscle or tendon sensors, they add important detail to the body's map of posture and alignment. The signals from all these receptors travel along sensory nerve fibers to the spinal cord, where some are used immediately for reflexes, and others ascend to the brain, particularly the cerebellum and the somatosensory cortex. The cerebellum, located at the back of the brain beneath the occipital lobe, plays a vital role in fine-tuning movement, balance, and coordination. It compares incoming proprioceptive information with visual and vestibular cues, helping the body to move smoothly and efficiently. Though it operates continuously, proprioception is usually unconscious. It functions in the background, guiding motion without the need for constant thought. But when something changes, when you stand on an uneven surface, or close your eyes while balancing on one foot, the brain brings this sense forward, allowing you to adjust in real time. This silent guidance is especially important during movement. Each step, each reach, each shift in weight requires a steady stream of proprioceptive feedback. It lets the brain know when to contract one muscle and relax another. It allows you to lift a glass without crushing it, or brush your teeth without poking your cheek. It tells you whether your limbs are moving in coordination or drifting out of alignment. Proprioception also works in concert with other senses. With vision, it refines spatial awareness. With the vestibular system, it supports balance. With touch, it informs how much pressure is being applied. This integration of information from different systems is known as sensoromotor integration, and it allows the body to move gracefully through even the most complex environments. Disruption of proprioception, whether through injury, illness, or neurological condition, can make even simple tasks difficult. Individuals with severe proprioceptive loss may need to watch their limbs constantly to know where they are. They may lose coordination, tire quickly, or feel as though their body is not fully their own. And yet, with practice and rehabilitation, other senses can often compensate, and new neural pathways can form. Proprioception is also central to many mind-body practices such as yoga, tai chi, and somatic movement. These disciplines heighten awareness of bodily sensation, often in slow and intentional ways, helping practitioners to refine their internal sense of position and alignment. Athletes and dancers, too, develop highly trained proprioception, allowing them to move with precision and confidence. In children, proprioception develops naturally as they grow and move, rolling, crawling, climbing, and running. All of these activities help build the internal map that guides posture and motion. Certain therapies for children with sensory integration challenges specifically target proprioceptive input, using weighted blankets, deep pressure, or resistance-based play to strengthen this inner awareness. And even in rest, proprioception continues. It tells you that your legs are stretched out, your head is turned slightly to one side, your arms are folded or at your side. It is part of how you know you are still in your body, even when your eyes are closed and your ears are quiet. It is a constant, gentle, grounding assurance of presence. So now, as you lie still, let the body speak softly. Feel the weight of your limbs, the shape of your spine, the gentle curve of your neck. Know that you do not need to move or adjust. The body already knows where it is. The sense of self, through the quiet workings of proprioception, is already whole, already aware. Let that awareness settle. Let the breath be slow, and know that even in stillness, the map remains the gentle knowing of the body from within. Part 10. Interoception. Listening to the body's interior world. Beneath the surface of the skin, beyond the sounds and lights of the outer world, lies another form of sensing quiet, continuous, and largely invisible. This is interoception, the sense of the body's internal state. It is the perception of hunger and fullness, thirst and satiety, the urge to breathe, the rhythm of the heartbeat, and the subtle stirrings of emotion. While other senses look outward, interoception turns gently inward. It is not tied to a single organ or region. Rather, it is a network of signals, a communication between the brain and the viscerate internal organs of the body. This sense allows you to know not only where your body is, but how it feels inside. Are you tense? Are you calm? Are you in need of rest, or food, or movement? These questions are not spoken, yet they are answered continuously in the quiet language of interoception. The signals of interoception originate in many places: the heart, the lungs, the gastrointestinal tract, the bladder, the muscles, and even the skin's deeper layers. Specialized sensory receptors detect changes in pressure, stretch, chemical composition, temperature, and inflammation. For example, baroreceptors in the blood vessels monitor blood pressure, while chemoreceptors sense levels of carbon dioxide in the blood, guiding the need to breathe. These internal messages travel through afferent nerve fibers, including branches of the vagus nerve, one of the most important highways of internal sensation. The vagus nerve carries signals from the viscera up to the brainstem, particularly the nucleus of the solitary tract, which serves as a relay station. From there, the information ascends to deeper regions of the brain, including the insula, a fold of cortex tucked within the lateral sulcus. The insula plays a central role in interpreting interoceptive data. It builds a moment-to-moment map of the body's interior condition, sometimes called the interoceptive body state representation. This map allows for the perception of both concrete signals, such as the need to urinate, and more diffuse sensations, such as anxiety or unease. In this way, interoception is closely tied to emotion, mood, and self-awareness. You might notice this in the way emotions are felt: a flutter in the chest when nervous, a heaviness in the stomach during grief, a lightness or warmth during joy. These sensations are not just metaphors, they are real interoceptive experiences. The body speaks through sensation long before the mind attaches words. In fact, many emotional and cognitive processes are deeply rooted in interoception. The perception of pain, the regulation of temperature, the sensation of fatigue, all of these rely on internal sensory input. Even decision-making and attention are influenced by how the body feels. When the heart rate rises, the brain becomes more alert. When the stomach is empty, thoughts drift toward food. This feedback system helps maintain homeostasis, the body's state of balance and stability. Interoception alerts the brain to internal disruptions and helps guide behavior to restore equilibrium, whether through eating, drinking, resting, or seeking warmth. It also contributes to the regulation of sleep, metabolism, and immune response. Importantly, interoceptive awareness varies from person to person. Some individuals are highly attuned to their internal signals. They can detect subtle shifts in heartbeat or breathing, or sense the early signs of hunger or stress. Others may feel more distant from these cues, either naturally or due to trauma, illness, or neurological variation. In clinical settings, differences in interoceptive processing have been observed in various conditions, including anxiety disorders, depression, eating disorders, and autism spectrum conditions. For example, heightened interoceptive sensitivity may contribute to anxiety, as ordinary bodily fluctuations like a slight increase in heart rate may be perceived as threatening. In contrast, reduced interoceptive awareness can make it difficult to recognize hunger or emotional cues. Still, interoception is not fixed. Like other senses, it can be gently trained and refined. Practices such as mindfulness, deep breathing, yoga, and body scanning encourage quiet attention to internal sensation. These practices can help calm the nervous system, improve emotional regulation, and deepen the connection between body and mind. In sleep, interoception continues. The brain monitors breathing, adjusts heart rate, and maintains the cycles of digestion. During dreams, bodily sensations may even be woven into the fabric of the imagined experience, blending the inner and outer worlds in subtle ways. Children, too, learn interoception gradually. They discover what hunger feels like, what it means to need rest, or how to respond to discomfort. Over time, this awareness helps shape autonomy and self-care. It fosters a sense of embodiment, that deep, quiet knowing that says, "This is me. This is how I feel." Interoception may be the most private of all the senses. Its signals are not visible to others. They are felt, sometimes faintly, sometimes vividly, always uniquely. And though it works silently, it forms the foundation for self-regulation, well-being, and presence. So now, as you lie at rest, the world outside may be quiet, but inside, there is a soft symphony of rhythm and breath, of heartbeat and warmth. The chest rises and falls, the lungs fill and release. The body listens to itself. Let yourself listen, tune out with effort, but with openness. You need not understand every signal. Just know that the system is working. The body is aware, and within that awareness, there is safety. There is calm. Let the breath remain steady. Let the heart move softly, and trust that the sense within the gentle awareness of being alive is holding you, quietly, from the inside out. Part 11. Multisensory integration. How the senses weave the world together. Imagine, for a moment, walking through a quiet forest. You feel the uneven ground beneath your feet, cool and soft. You hear the distant rustle of leaves stirred by wind. You smell the damp earth and faint traces of pine. Sunlight filters through the canopy above, painting golden patterns across your vision. And without needing to analyze, you know where you are, what direction you're facing, how you're moving, and how you feel. This seamless awareness is made possible by multisensory integration, the brain's quiet ability to gather, combine, and harmonize information from all the senses at once. Though we often speak of sight, sound, touch, and so on as separate channels, in truth, they are rarely experienced in isolation. Instead, they form an intricate tapestry of perception, gently woven together by the nervous system. At the center of this weaving is the brain, particularly regions such as the superior colliculus, posterior parietal cortex, and the insula, each of which helps merge sensory inputs into coherent experiences. These regions do not merely combine signals, they interpret, prioritize, and adjust them based on context and relevance. Consider the simple act of catching a ball. Your eyes track its motion. Your hands sense its impact. Your muscles adjust in anticipation. All of this unfolds in a fraction of a second, relying on precise coordination between vision, proprioception, and touch. If any one system falters or lags behind, the action becomes clumsy. But when they align, the motion feels natural, effortless. Even perception of something as basic as location depends on this integration. When you touch your own hand in the dark, the brain aligns visual absence with tactile presence and proprioceptive feedback. You know where your hand is because multiple systems agree upon it, reinforcing the internal map of the body and the external map of space. This unity becomes especially clear when the system is disrupted. In certain neurological conditions, the brain may misinterpret sensory input, leading to sensations that are out of sync, seeing a movement before hearing its sound, or feeling a touch without localizing it correctly. Such moments remind us that the smoothness of experience is not automatic, but the result of intricate cooperation. Temporal alignment is one part of the integration process. The brain must judge whether signals arriving at slightly different times still belong to the same event. This is why lightning can be seen before thunder is heard, and yet both are understood to be linked. The brain extends a small window of time, milliseconds, long during which it considers sensory inputs as part of a single cause. This is known as the temporal binding window. Spatial alignment is equally important. Sounds are often more clearly understood when the source can be seen. This is why conversations are easier when watching someone's face. The brain aligns the moving lips with the sound of speech, allowing for greater clarity. If the visual and auditory cues are misaligned, comprehension becomes more difficult. In laboratory settings, this mismatch can even produce illusions, such as the McGurk effect, where seeing one sound and hearing another leads to the perception of a third, blended sound. Other multisensory illusions include the rubber hand illusion, where a fake hand is placed in front of a person and stroked in synchrony with their hidden real hand. After a short time, the brain integrates the visual and tactile cues, and the fake hand begins to feel like part of the self. These illusions demonstrate just how flexible and suggestible the sense of body and world can be. Yet most of the time, the system functions in perfect quiet. You sip tea, tasting warmth, smelling its aroma, seeing the steam rise. You walk through a room, orienting through vision, balance, and the soft feedback from your feet. Even in dreams, multisensory experiences continue as the brain constructs entire scenes from memory, imagination, and internal cues. This integration is also deeply tied to emotion and attention. A scent may become more vivid if it is linked to a memory. A sudden sound may seem louder if unexpected. The brain adjusts its focus based on relevance, enhancing signals that matter and softening those that do not. This dynamic shaping of experience ensures that we are not overwhelmed, but gently guided through each moment. Children develop multisensory integration gradually. In infancy, Senses operate somewhat independently, but through experience, the brain learns to associate patterns such as the sight and sound of a parent's voice or the feel and taste of food. These associations become stronger over time, forming the foundation for perception, learning, and movement. And as with all senses, this integration can be nurtured. Certain practices like mindful movement, nature immersion, or slow, intentional eating encourage awareness of multiple senses working together. These moments, when we pause to truly notice, can restore a sense of connection to the body, to the environment, to the present. Importantly, multisensory integration also supports the sense of self. It affirms that the body is whole, that the world is stable, and that you are part of it. When the senses work in harmony, there is a quiet coherence of felt rightness that allows the mind to relax, to trust, to let go. So as you rest now, your senses continue their work. Even in darkness, even in stillness, they remain quietly attuned. The body listens inward and outward at once, balancing the heartbeat with the hush of air, the position of limbs with the softness of breath. You do not need to think about these processes. They are already in motion. They have always been. Your body knows how to sense, how to integrate, how to feel at home. Let the systems settle. Let the inner world and outer world drift together. And know that even in sleep, the senses weave on, holding you in their quiet embrace. Part 12. Sensory Development and Aging. The Lifespan of Perception. From the first stirrings in the womb to the soft quiet of old age, the human senses follow a gentle arca rhythm of growth, refinement, and gradual change. Each sense develops along its own timeline, influenced by genetics, environment, experience, and time. And while no two sensory journeys are exactly alike, the broad patterns of development and aging are shared by all. Before birth, the senses begin to form. Touch is the earliest to emerge, detectable by around 8 weeks of gestation. By the second trimester, the fetus responds to gentle pressure on the skin. Taste and smell follow soon after. Amniotic fluid, rich with the flavors of the mother's diet, flows over developing taste buds, subtly shaping early preferences. The sense of hearing begins around the 20th week, allowing the fetus to perceive muffled sounds from the outside world, especially rhythms and tones. Sight is the last to awaken, as the dim environment of the womb offers little stimulation for the eyes. By birth, the senses are active, though not yet mature. A newborn can see, but with limited clarity. They focus best on faces, especially those held close. Their hearing is tuned to higher-pitched voice, especially the soft melodic tones often used by caregivers. Touch is fully functional, and the baby responds to warmth, to pressure, to the comfort of being held. Taste and smell are already guiding forces. A newborn can distinguish sweet from bitter and will turn toward the scent of the mother's milk. Throughout infancy and early childhood, the senses develop rapidly. Visual acuity sharpens, depth perception forms, and color vision becomes more refined. Hearing becomes more selective, allowing the child to recognize familiar voices and patterns. Motor skills improve as proprioception and vestibular senses mature. The body learns to crawl, to stand, to balance. Each movement is both practice and refinement, a way of tuning the brain to the messages of the senses. This is a time of neuroplasticity, when the brain is most flexible, most capable of adapting and learning from sensory input. Experiences in early life lay the groundwork for later perception. A child exposed to rich sensory environments, textures, sounds, movement, variation develops more robust pathways for integrating those sensations. Play, especially physical and exploratory play, becomes a central part of sensory growth. By middle childhood, the senses have largely stabilized. Vision, hearing, taste, touch, and balance work together smoothly. The child is aware of how the body moves through space, how to respond to stimuli, how to focus attention. Emotional experiences become more intertwined with sensory perception. A certain song brings joy, a texture brings comfort, a particular scent reminds them of home. During adolescence, subtle changes begin. Hormonal shifts can affect sensory perception, especially in terms of smell and taste. The brain continues to refine its integration of information, improving attention, coordination, and decision-making. Emotional intensity may heighten sensory experiences. Music may feel more vivid, physical sensations more intense. This period also brings greater awareness of self and body image, often influenced by the sensory feedback received from others and the world. Adulthood represents the peak of sensory function for most individuals. The senses are finely tuned, the brain adept at filtering and interpreting complex environments. Yet even in this phase, variation is normal. Some senses, such as taste or hearing, may begin a slow decline, often so gradual it goes unnoticed. The body continues to adapt, compensating for minor losses with greater experience and cognitive strategies. As the years progress into later adulthood, the senses begin to shift more noticeably. Vision may dim slightly, especially in low light. The lens of the eye stiffens, making it harder to focus up close. The retina may lose sensitivity, and contrast becomes more difficult to discern. Hearing, too, can fade, particularly the ability to detect high-pitched sounds or to follow conversations in noisy environments. Taste and smell may also diminish, often together. The number of taste buds declines, and the olfactory receptors in the nose become less responsive. Food may taste blander, and appetite may change. Yet the emotional and social aspects of eating often remain deeply satisfying, supported by memory and ritual. Touch and proprioception may become less precise. The skin thins, and the density of sensory receptors decreases. Reflexes slow. Balance may become more fragile, requiring more conscious attention to posture and movement. The vestibular system, too, becomes more delicate with age, increasing the risk of dizziness or unsteadiness. Despite these changes, the body and brain are remarkably adaptable. The mind learns to rely more on vision if hearing fades, or to focus attention more carefully if sensation weakens. Assistive devices, environmental adjustments, and mindful practices can all support continued sensory engagement. In fact, for many older adults, sensory experience becomes more intentional. There may be more time to savor the warmth of sunlight through a window, the texture of fabric, the taste of a familiar meal. Simple sensations become anchors of presence, sources of comfort and continuity. Cognitive functions, too, remain deeply connected to the senses. Memory is often triggered by scent or sound. Emotional regulation is supported by touch and breath. Social connection continues through voice, eye contact, and shared physical space. And while aging brings change, it also brings depth. The senses may lose sharpness, but gain resonance. A song heard in youth may echo more powerfully in later life. A familiar scent may carry a lifetime of meaning. Sensory experience becomes layered not only in the moment, but in memory. Throughout life, the senses teach us how to move, how to relate, how to feel. They shape perception, behavior, and identity. They connect the inner world with the outer one, and even as they shift and soften with time, their presence remains essential. So now, wherever you are in your own arc of experience, let the senses rest. Let them soften. Know that whether they are sharp or subtle, active or at ease, they are part of your wholeness. They have carried you through seasons of growth, moments of stillness, and times of wonder. Let that quiet knowing settle over you. Let the breath slow. Let the body rest. wrapped in its gentle awareness. The senses are still with you, even now, even in stillness. Part 13. The brain and the senses. How perception is shaped from within. The senses begin at the edges of the body on the skin, in the eyes, ears, nose, and tongue, but their work is not complete until their signals reach the brain. It is here, in the folds and pathways of neural tissue, that sensation becomes perception, light becomes sight, vibration becomes sound, molecules become flavor. And from these quiet translations, a world appears not raw or objective, but shaped, filtered, interpreted. The brain is not a passive receiver. It is an active sculptor of experience. It does not simply record the world, it builds it. Using input from the senses, along with memory, attention, expectation, and emotion, the brain forms a coherent picture of reality. This picture feels whole, fluid, and stable. Yet it is always a construction beautifully reliable, yet quietly subjective. At the core of this process are the sensory cortices, each devoted to processing information from a particular modality. The primary visual cortex, or VONE, located in the occipital lobe, interprets signals from the retina. It detects edges, shapes, motion, and color. The primary auditory cortex in the temporal lobe decodes sound waves into pitch, rhythm, and meaning. The primary somatosensory cortex in the parietal lobe maps the surface of the body registering touch, temperature, and pain. The olfactory cortex, connected closely with the limbic system, translates scent into memory-laden perception. The gustatory cortex, nestled near the insula, interprets taste, often in combination with smell and texture. These regions are highly specialized, yet interconnected. As sensory signals reach the brain, they do not remain isolated. They are compared, combined, and contextualized. Information flows not only forward but also backward. Higher regions of the brain send feedback to lower ones, shaping what is noticed and what is ignored. This is how attention works. It is why, in a crowded room, you can focus on one voice and let the others fade. The thalamus, deep in the brain center, acts as a kind of relay station for most senses. It filters incoming signals, deciding what to forward to the cortex. Exceptions include the sense of smell, which bypasses the thalamus and travels directly to the limbic structures, perhaps explaining its unique power to evoke emotion and memory. Beyond primary processing areas, the association cortices handle more complex integration. These are the regions where raw sensations become recognizable objects, faces, words, or emotional tones. They allow the brain to not just see color, but to recognize a familiar room, not just hear a sound, but to know it as a voice, or a bird, or a song. Perception is also shaped by expectation. The brain constantly predicts what will happen next. When the prediction is correct, perception feels smooth and accurate. When it is wrong, the brain adjusts, sometimes creating surprising effects. This process, known as predictive coding, helps explain optical illusions, auditory hallucinations, and even phantom sensations. It also underlies learning and adaptation. Memory plays a powerful role in this process. What we've experienced in the past colors how we interpret the present. A scent reminds us of a childhood room. A touch feels safe or alarming, depending on history. The brain does not process the world anew each time. It weaves new data into a story already in progress. Emotion, too, influences perception. A sudden noise may seem louder when we are anxious. A gentle touch may feel warmer when we are calm. The amygdala, insula, and anterior cingulate cortex are deeply involved in the emotional coloring of sensory experience. They help the brain decide what matters, what to remember, what to approach, or avoid. In this way, the senses are not separate from the mind. They are the mind in action. They provide the raw material for thought, memory, identity, and awareness. And the brain, in turn, gives the senses their meaning. Damage to sensory areas of the brain can have profound effects. Lesions in the visual cortex can cause blindness, even when the eyes are intact. Damage to the somatosensory cortex may lead to numbness or loss of body awareness. In rare cases, individuals with intact hearing and sight may be unable to recognize common sounds or face a condition known as agnosia, because the brain cannot connect sensation with stored knowledge. At the same time, the brain is highly plastic, especially when young. If one sense is lost, others may become more sensitive. Blind individuals often develop enhanced hearing or touch. The brain reallocates resources, building new connections to adapt to change. Even in adulthood, neuroplasticity allows for learning, compensation, and recovery. This plasticity also explains how the brain accommodates sensory devices such as hearing aids, cochlear implants, glasses, or tactile feedback systems. Over time, the brain learns to interpret these signals, blending them into the perceptual experience, as if they had always been there. Modern neuroscience has revealed another surprising truth. Even in the absence of external input, the brain can generate sensory-like experiences. Dreams, for instance, are composed of sensory fragment sites, sounds, feelings woven together during sleep. Mental imagery and inner speech are similarly based on internal activations of sensory regions. The brain, it seems, can create its own reality, using the same circuits it uses to perceive the outside world. And so, perception is not a mirror, but a canvas. Each sense contributes color and form. The brain provides shape and structure, and together, they create the lived experience of being in the world moment by moment, gently, continuously. As you rest now, the brain continues to listen, not to every sound or flicker of light, but to the rhythms of breath, the stillness of posture, the soft pulse of calm. Even as consciousness fades, the senses remain loosely tethered, gently modulated by dreams, by memory, by silence. There is nothing you must do, no signal to interpret. The brain will carry you through the night, quietly weaving experience from within. Part 14. The emotional layers of sensation. The senses do not exist in isolation. They are not merely tools of detection or measurement. They are, at every moment, infused with feeling. Each sound, each texture, each flicker of light is touched quietly by emotion, not as an addition, but as an inseparable layer. Sensation and emotion are not two paths. They are woven into one fabric. To understand the emotional depth of the senses, we must begin with their direct connections to the parts of the brain responsible for feeling. Unlike abstract thought or language, emotional responses are often immediate, visceral, and sensory bound. Take, for instance, the sense of smell. Of all the senses, it has the most direct route to the limbic system, the brain's emotional and memory center. When a scent enters the nose, it is carried not only to the olfactory cortex, but also to the amygdala and hippocampus, regions that govern fear, comfort, longing, and recall. This is why a simple scent-dusty books, pine resin, fresh bread can trigger deep feelings, sometimes without warning. Sound, too, reaches us emotionally before it reaches us intellectually. A minor chord, a familiar voice, the rustle of leaves, or the hush of waves can elicit sadness, peace, joy, or a curious melancholy. These feelings are not chosen. They arise naturally, as part of how the brain receives vibration. The auditory cortex, while decoding pitch and rhythm, sends parallel signals to areas of the brain that assign emotional meaning, especially the insula and anterior cingulate cortex. Touch, perhaps more than any other sense, is intimately tied to comfort. The earliest sensations we know are tactile pressure of a caregiver's arms, the warmth of skin, the rhythm of rocking. These first experiences lay the foundation for how we understand safety and connection. Even in adulthood, a soft blanket, the weight of a hand, or the texture of warm water can evoke feelings of trust and calm. The skin, in this way, becomes not only a boundary, but a medium for emotion. Sight also carries emotion, though in quieter ways. A familiar room bathed in golden light, a face, soft with memory, the contrast between cool shadows and warm sun. These visual elements stir feeling, not because they demand attention, but because they resemble something held within. The brain's visual and emotional centers collaborate constantly, comparing what is seen with what is felt and what has been felt before. Even taste, often considered practical or routine, holds emotional resonance. A favorite childhood flavor, a meal shared in love, or the bittersweet aftertaste of something once loved and now lost, these are more than sensations. They are emotional time capsules, experienced through the tongue, but remembered through the heart. Beyond the individual senses, emotion shapes how we perceive altogether. When we feel anxious, the world seems louder, sharper, more crowded. When we are calm, the same world appears slower, softer, and more welcoming. This shift is not imagined, it is neurological. Emotional states alter the sensitivity of sensory systems, changing not just what we notice, but how we interpret it. The autonomic nervous system, which governs states of arousal and rest, plays a central role here. In moments of stress, it increases vigilance. The pupils widen, the hearing sharpens. Touch may feel more intrusive. In moments of safety, the system returns to baseline. The breath deepens, vision softens. The body allows sensation to unfold without defense. This interplay between emotion and sensation is especially significant for individuals with heightened sensory awareness. For some, sensory input is rich, intense, and emotionally charged, even in quiet moments. For others, it may be distant, slow to register, or difficult to link with feeling. Neither experience is wrong. Both are simply expressions of the deep connection between the outer world and the inner world. And yet, emotion does not only affect how we perceive it, it is also shaped by what we sense. Sensory environments can nurture peace or trigger unease. A softly lit space with gentle sounds and calming textures invites the nervous system to rest. A cluttered, noisy, bright environment may subtly heighten arousal. Over time, these sensory emotional associations become patterns. They guide behavior, memory, and mood. This is why the senses are so often used in therapeutic settings. Music calms, aromatherapy soothes, weighted blankets provide grounding, gentle movement and touch can help release stored tension. Each intervention speaks the quiet language of sensation, reminding the body how to feel safe, how to return to stillness. Even in solitude, the emotional power of the senses remains. The flicker of candlelight, the sound of distant wind, the texture of a stone or a piece of wood held in the hand. These small moments are not empty. They are full of quiet feeling. They invite reflection, and sometimes healing. And in sleep, where the body rests and the mind drifts free, sensation and emotion blend into dream. A sound may become a symbol, a warmth may become a memory. The senses, though dulled, remain active still, shaping the mood of night. So let us return now to the simplicity of the moment. Let the eyes close. Let the muscles ease. Let the breath soften. Let sensation be felt without judgment. Let emotion rise and fall like the tide gently, naturally. There is no need to understand it all, only to notice, only to be present, only to rest. The emotional layers of sensation are not burdens to carry. They are invitations to listen more closely, to feel more deeply, to return more fully to oneself. Part 15. Variation in sensory perception among individuals. Though we often speak of the senses as shared and universal, the truth is that no two people perceive the world in quite the same way. Each individual lives within a unique sensory envelope shaped by genetics, life experience, environment, health, and even emotion. Sight, sound, touch, and the rest are not fixed systems, but personal and adaptive, varying subtly or profoundly from one person to the next. This gentle diversity in sensory perception adds color and texture to the human experience. It means that the same breeze may feel refreshing to one person and cool to another. A certain food may taste rich and flavorful to some, but bland or overwhelming to others. A piece of music may move one listener to tears, while leaving another untouched. Let us begin with vision, often considered the dominant sense. While most people perceive a similar range of visible light, there are individual differences in color perception, acuity, and sensitivity to contrast or brightness. For example, those with color vision deficiency, commonly called color blindness, may have difficulty distinguishing reds from greens or blues from yellows. This condition affects approximately 1 in 12 men and 1 in 200 women. Despite the name, most individuals with color vision differences still perceive color just in a different balance or spectrum. On the other end of the visual spectrum, some people may possess tetrachromasia, a rare condition, typically found in some women, involving a fourth type of color receptor in the eye. This may allow for a richer or more nuanced perception of shades, though such experiences are often hard to describe or measure. As with many sensory traits, the uniqueness lies not just in biology, but in how the brain interprets what the eye receives. Hearing, too, varies widely among individuals. Differences in frequency sensitivity, auditory memory, and sound localization are common. Some people are more attuned to high-pitched sounds, while others may notice subtleties in rhythm or tone more easily. Individuals with perfect pitch, for instance, can identify musical notes without any reference, a rare trait tied to early exposure and neurological wiring. Hearing loss, meanwhile, may be partial or gradual. Many people experience mild declines in hearing with age, particularly at higher frequencies. Others may have a lifelong difference, such as conductive or sensorineural hearing loss, or experience the world primarily through vibration and visual cues. In all cases, the auditory experience is deeply personal, shaped by both ability and adaptation. In the realm of smell and taste, variations are especially subtle and complex. Genetic differences influence how we detect certain compounds. For example, the ability to smell androstenone, a musky scent found in some natural body odors, varies greatly. Some perceive it strongly, others barely at all. Taste, similarly, is affected by the number and distribution of taste buds. Some people are super tasters, with heightened sensitivity to bitter flavors, while others may be non-tasters, less reactive to certain tastes. These differences affect not just preference, but appetite and dietary choices, often without conscious awareness. Touch, too, varies along a spectrum. Some individuals are highly sensitive to textures, temperature changes, or pressure. Others may experience a more muted or delayed perception of contact. These differences can be biological or shaped by life events, such as injury, neurological conditions, or sensory-focused experiences like massage, physical training, or repetitive use. In particular, certain neurodiverse individuals, such as those on the autism spectrum, experience sensory processing differences. For some, everyday sensations like bright lights, background noise, or certain fabrics may feel overwhelming or distracting. For others, Sensation may be under-responsive, requiring more intensity to register. These variations are neither flaws nor deficits, but part of the broad and natural range of human perception. Proprioception and interoception also show quiet diversity. Some people have a keen sense of body position and balance, enabling graceful motion and coordination. Others may find their awareness of posture or motion less defined, requiring conscious effort to adjust. Interoceptive sensitivity, the awareness of internal states like hunger, thirst, or heart rate, also differs. While some are highly attuned to their internal rhythms, others may sense only stronger or more obvious signals. These differences are not simply random. They may be influenced by development, genetics, illness, trauma, or even cultural habits, and they often change over time, growing stronger, softer, sharper, or quieter, depending on age, lifestyle, and environment. The brain plays a central role in interpreting and regulating sensory input. Two individuals may receive the same raw stimulus, but experience it differently based on attention, emotion, and expectation. A familiar scent may be comforting to one and unpleasant to another, not because of the chemical makeup, but because of the memory it evokes. And the senses, remarkably, are trainable. With practice, one can learn to hear more notes in a piece of music, detect more flavors in food, or become more aware of body signals. Dancers and athletes refine proprioception. Musicians refine auditory sensitivity. Chefs refine smell and taste. This neuroplasticity reminds us that sensory experience is not fixed. It can evolve, adapt, and deepen with time and attention. Even technology now expands the range of sensation. Hearing aids, cochlear implants, glasses, haptic feedback devices, and sensory substitution tools allow individuals to access the world through new channels. These tools do not replace sensation, they translate it, offering fresh pathways for perception. Ultimately, the variation in sensory perception is a quiet celebration of human diversity. It shapes how each of us moves, connects, feels, and understands. It reminds us that what is soothing for one may be stimulating for another, and that there is no single normal way to perceive the world. And so, as you rest now, know that your own way of sensing, however sharp, soft, bright, or mutedous, a valid and natural expression of being. The world is not the same for everyone, and that is part of its richness. Each perception is a brushstroke in the quiet canvas of life. Let that thought soften your breath. Let it ease your mind. You are sensing in your own way, at your own pace, and that too is beautiful. Part 16. The role of memory and learning in sensation. To sense the world is not only to receive raw input, but to interpret it, place it in context, to weave it gently into the tapestry of memory and meaning. From the moment we begin to experience life, the senses are not passive. They are shaped, refined, and even changed by what we learn, what we remember, and what we feel. Memory and sensation are intertwined. What we see, hear, smell, and touch does not vanish in the moment it's perceived. It is stored, consciously or not, in networks of neural connection. And these stored impressions influence every new sensation that follows. We taste a familiar flavor and are transported to a childhood kitchen. We hear a melody and remember a long-forgotten afternoon. We feel a certain fabric and recall a place we once rested. This gentle echo between the past and the present is not a flaw in the sensory system, it is a strength. The brain does not treat each sensation as new. Instead, it compares incoming information to existing patterns, allowing us to recognize, anticipate, and respond more quickly and more calmly to the world around us. One of the most vivid examples of this connection is olfactory memory. Because the sense of smell bypasses the thalamus and connects directly with the amygdala and hippocampus regions involved in emotion and memoriscence, often carry a deep emotional charge. A whiff of perfume, soil after rain, or warm bread can stir feelings and memories so suddenly, they seem to rise from the body itself. Sound also plays a powerful role in memory. A single chord, the rhythm of footsteps, the tone of a voice, these can all call forth entire emotional landscapes. This is why lullabies comfort even in adulthood, and why certain ambient sounds, like gentle rain or ocean waves, are used in relaxation and sleep. The auditory cortex, along with the hippocampus and prefrontal cortex, tags these sounds with emotional tone and familiarity, allowing them to return with clarity even after many years. Visual memory is often rich in spatial detail. The brain remembers not only what something looked like, but where it was and how it was arranged. This is part of how we navigate familiar spaces with ease. We know the shape of a room, the location of a doorway, the height of a shelf often, without conscious thought. Over time, the brain builds these internal maps, combining sight, proprioception, and touch into a memory of place. Learning plays an equally important role in how we perceive. As we move through life, the senses become more selective. The brain learns what to focus on, what to ignore, and how to filter background noise from foreground information. A musician learns to hear subtle harmonics. A tea maker learns to taste fine distinctions in flavor. A woodworker learns to feel the grain of different trees. These are not innate gifts, but skills of attention, honed through repetition and care. The ability to habituateto, stop noticing a constant stimulus, is also a form of learning. We grow used to the feeling of clothing, the hum of a fan, or the ticking of a clock. This frees the brain to focus on new or changing information. But with mindfulness, even the familiar can become vivid again. A practiced awareness can restore freshness to sensation, allowing us to feel the texture of water, the warmth of light, the softness of breath. Associative learning also shapes perception. If a sound or scent is consistently paired with a particular outcome, comfort, safety, tension, or reward, the body and brain begin to anticipate that outcome automatically. This is the gentle mechanism behind conditioning, a quiet shaping of response that happens across the senses. Sometimes, learned responses become so deeply embedded that they shape reflexes. The startle reflex, for example, may be more sensitive in someone who has experienced trauma. A certain tone of voice or quality of light may evoke discomfort or alertness without clear reason. These responses are not always under conscious control, but they are part of how the brain tries to protect, to remember, to adapt. The interplay between memory and sensation is also seen in phantom perceptions. A person who loses a limb may still feel its presence. Someone who loses hearing may still hear a remembered melody. These sensations arise not from the senses themselves, but from the brain's continued activation of old pathways, reminders that perception does not begin and end at the body's surface, but lives in the spaces memory has carved within. Even in dreams, sensation and memory mingle. The brain reactivates patterns of sound, touch, light, and movement, often rearranged into new sequences. These dream sensations feel real not because the senses are engaged, but because memory supplies the texture. A place you have not visited in years may return in vivid detail. A voice, long silent, may speak again. Children's brains are especially sensitive to sensory learning. In early life, each touch, each taste, each sound becomes a lesson. Repetition strengthens neural circuits, while novelty sparks curiosity and growth. This is why early exposure to music, language, movement, and varied textures is so nourishing. It builds a wide and flexible foundation for lifelong perception. And throughout life, the ability to relearn remains. After injury, the senses can reroute. After loss, new meanings can be found. The brain does not forget how to feel. It only pauses, waits, reconfigures. With time and care, it opens once more to sensation often softer, often slower, but still deep and full. So now, as you rest, know that each sensation, each whisper of air, each flicker of thought is not isolated. It is part of a long, gentle story of learning, remembering, adapting, and becoming. You carry within you the memory of touch, of sound, of warmth. You carry the imprint of light and motion, of rhythm and stillness, and all of it, quietly, has shaped the way you sense the world. Let that memory rest with you now. Let it soften into stillness. Let it cradle you mind, body, breath until sleep returns you to that place where sensation and memory meet in silence. Part 17. Sleep and the Senses. A quiet interlude. As day fades into night and the world grows quiet, the senses too begin to soften. Their work does not stop entirely, but it slows, shifts, and turns inward. In sleep, we enter a realm where sensation continues but gently, distantly, as if viewed through a veil. Sleep is not the absence of perception. It is a reorganization of perception. The brain does not shut down. Rather, it changes its rhythm, cycling through phases of deeper rest and lighter awareness. And throughout this cycle, the senses remain present, though altered, partially disengaged from the outer world, partially attuned to inner signals. As we drift into sleep, the thalamus, that central relay station of the brain, begins to filter out incoming sensory information. It dampens the flow of data from the eyes, the ears, the skin, the muscles. This filter is not complete, but it creates a buffer allowing the sleeper to remain undisturbed by minor stimuli while still capable of waking if needed. Hearing is often the last sense to rest. Even in deep sleep, the auditory system remains alert to certain patterns, like a baby's cry, a name spoken softly, or the ring of a familiar tone. This is why certain sounds, particularly rhythmic or gentle ones, are used to encourage relaxation and sleep. Rainfall, ocean waves, soft breathing. These sounds are not distractions, but invitations. They guide the mind toward slowness, creating a gentle bridge from wakefulness to sleep. Touch, too, remains partially awake. The pressure of the bed, the softness of fabric, the warmth of a blanket continue to be registered, though they fade into the background of awareness. If a sensation becomes sharp or uncomfortable, a shift in temperature, a twisted sheet, a sudden draft, it may awaken the sleeper or disrupt the rhythm of rest. But under ordinary circumstances, the tactile world becomes muted, a steady comfort rather than a call to action. Vision becomes dormant quickly. With the eyelids closed and the optic nerves receiving no new light, the visual cortex rests, yet it does not sleep entirely. In dreams, it awakens once more, not to external light, but to internally generated imagery. The brain constructs entire scenes, places, faces, colors, movement without any input from the eyes. This dream sight is vivid, often more fluid and imaginative than waking vision, as it is not constrained by the rules of the outside world. Smell and taste play a quieter role in sleep. Their receptors remain active, but their impact on consciousness is gentler. A strong odor may stir a sleeper or influence a dream, but most scents fade into the softness of night. Still, familiar fragrances like lavender or warm linen can ease the transition to rest. They create a sense of calm and safety, engaging the emotional memory centers in subtle, soothing ways. The vestibular system, which governs balance and spatial orientation, enters a restful state. With the body still and supported, there is little motion to track, but it does not shut down entirely. If the sleeper rolls, or shifts, or dreams of falling, the system re-engages briefly to update the brain's map of position. This is why sudden movements during dreams can feel startling, like slipping or floating, because the sense of body and space momentarily becomes disjointed. Proprioception, the sense of body position, also quiets. With no active movement, the muscle spindles and joint receptors offer a constant, low stream of information. This background awareness maintains a soft connection to the body enough to allow for turning, adjusting, or curling in response to comfort. In this way, the sleeper remains safely aware of their own form even in stillness. Perhaps the most active sense during sleep is interoception, the inward awareness of the body's internal state. The brain continues to monitor heart rate, breath, temperature, and digestion. It adjusts rhythms, restores balance, and supports healing. The respiratory system slows. The heartbeat becomes steady. The immune system activates its gentle repair processes. This is the quiet work of the sleeping body, guided by sensation, but governed by automatic wisdom. And through all this, the mind drifts in and out of dreams, those mysterious narratives spun from memory, imagination, and faint echoes of the day. Dreams are not bound by the senses in the usual way, yet they are rich in sensory detail. We see, hear, and touch within them. We move and float, speak and listen, though the body lies still. It is as though the senses have turned inward, creating a world of their own. Dreams remind us that sensation is not limited to the external. The brain can generate its own impressions, shaped by the same circuits that interpret waking experience. This continuity between day and night, between outer world and inner vision, speaks to the depth of the sensory system, not just as a set of tools for survival, but as the foundation for consciousness itself. As morning approaches, the senses begin to stir. Light filters through the eyelids. Sound becomes sharper. Touch regains its texture. The brain, emerging from the slower waves of sleep, resumes its usual rhythm. And once again, the senses open like petals in sunlight, ready to receive the world. But now, in this quiet moment, you remain between those states, not fully asleep, not fully awake, floating gently, still supported by the softness of sensation. The body knows how to rest. The senses know how to fade. Let them drift. Let them soften. Let the last traces of thought dissolve into breath. There is nothing you need to sense now, to no signal to interpret, no message to follow. Only stillness, only peace, only the soft echo of a world that continues, gently, around you, as you rest. Part 18. Disorders of sensory processing. Very gently. Not all sensory experiences are smooth. For some, the flow of sensation is louder, sharper, more erratic. For others, it is distant, muted, or confusing. The brain, in its quiet orchestration of perception, sometimes processes sensory signals in a way that feels disorganized, overwhelming, or out of step with the environment. These experiences fall under the gentle umbrella of sensory processing differences, also called sensory processing disorders. Though the term can sound clinical, the experiences it describes are very human. They are part of the wide, natural spectrum of how people relate to their bodies and the world. These differences are not always visible. They may pass unnoticed in casual conversation, but for those who live with them, they can shape how a room feels, how a voice sounds, or how a simple touch is received. At the heart of sensory processing challenges is a mismatch between sensory input and the brain's interpretation. For example, a sound that is background noise to most may feel painfully sharp to someone with auditory sensitivity. A light touch on the arm, meant as comfort, might instead feel jarring or invasive. These sensations are not imagined or exaggerated, they are real perceptions, shaped by genuine neurological differences. Some people experience sensory over-responsiveness. This means that sensory input such as bright lights, loud noises, strong smells, or certain textures can feel overpowering or distressing. These individuals may avoid busy environments, struggle with certain fabrics, or need more time to adjust to changes in temperature or lighting. The nervous system is not broken, it is simply tuned differently, often more finely. Others may experience sensory under-responsiveness. In this case, sensory input may not register strongly. A person might not notice pain right away, or may seek more intense input to feel balance, pressing hard against surfaces, moving constantly, or craving deep pressure. These behaviors are not random, they are efforts by the body to locate itself in space, to anchor perception in a way that feels right. There are also individuals who experience sensory-seeking behaviors. These may include spinning, jumping, humming, touching objects repeatedly, or gravitating toward intense colors or patterns. These actions are ways of regulating internal state, soothing, stimulating, or grounding the nervous system through purposeful engagement with sensation. Sensory processing differences often appear in children, but can persist or evolve throughout life. They are commonly observed in individuals with autism, ADHD, anxiety disorders, and other neurodevelopmental conditions, but they can also occur independently in people of all backgrounds, with or without diagnoses. Each sensory system, vision, hearing, touch, proprioception, interoception, may be affected differently. These variations are not flaws. They are not failures of development. They are simply differences in how information is received, filtered, and experienced. And with understanding, support, and the right environment, individuals with sensory processing differences can thrive, adapt, and even flourish. Occupational therapists often work gently with sensory integration techniques. These may involve slow exposure to textures, movement games, calming routines, or deep pressure activities like weighted blankets. The goal is never to normalize sensation, but to help individuals find balance, comfort, and control in their unique sensory world. It is also important to recognize the emotional impact of sensory differences. When the environment feels unpredictable, when everyday experiences become sources of stress or discomfort, anxiety can rise. Fatigue may build. Social interactions may become more difficult, not because of lack of desire, but because the sensory demands are high. In these moments, patience and quiet support are powerful tools. Respecting sensory boundary is turning down the volume, offering dimmer light, providing calming spaces can make a world of difference. There is deep kindness in creating environments that welcome all types of sensory experience, not just the typical ones. Just as no two people see the world the same way, no two sensory experiences are alike. Some may find joy in spinning lights, while others seek silence. Some may crave firm pressure, while others shy away from a breeze. These needs are personal. They are part of the gentle diversity of human perception. And while the challenges can be real, the gifts of sensory difference are often profound. A heightened sensitivity to sound may allow someone to appreciate the delicate tones in music. A deep connection to texture may bring joy in fabrics, nature, or art. A strong proprioceptive need may lead to graceful movement or powerful athleticism. Even sensitivity to emotion and social energy, what some might call intuitive perception, can be tied to rich interoceptive awareness. So let us speak softly of these differences, not with fear, but with care. The nervous system is not always predictable. It does not always move in harmony with the outside world, but it is always trying, always listening, always learning. If you or someone you care for experiences sensory processing differences, know that there is nothing wrong. There is simply a different rhythm, a different filter, a different way of being. Let that truth rest with you now. Let it soften the edges of worry. You are sensing in the way your body knows how. You are responding in the way your mind understands best. You are doing enough. As you lie here, safe and still, the world need not press in. The lights can dim, the sounds can fade, the textures can settle, and in that softened space, may the senses find peace, just as they are. Part 19. The beauty of sensory diversity across the animal kingdom. We are not alone in sensing the world. Across the forests and oceans, deserts and skies, countless living beings experience reality in ways both similar to and vastly different from our own. Each creature carries a suite of senses, shaped gently by evolution, adapted to its niche, honed for survival, but also for beauty, balance, and connection. To explore the animal kingdom through the lens of sensation is to witness a quiet, endless creativity. The human senses, though rich and complex, represent only one way of perceiving. Nature, in her quiet wisdom, has sculpted sensory abilities far beyond human limits. And in doing so, she has painted a world that is layered, shifting, and infinitely more vibrant than we often realize. Consider, first, vision. Humans see within a narrow band of the electromagnetic spectrum what we call visible light. Yet many animals see beyond these limits. Bees and butterflies, for instance, perceive ultraviolet light, allowing them to detect patterns on flowers that guide them toward nectar. These patterns are invisible to human eyes, but to the bee, they are like glowing roadmaps, pulsing with color and shape. Birds of prey, such as eagles and hawks, possess extraordinary visual acuity. Their eyes contain more photoreceptor cells per square millimeter than human eyes, allowing them to detect the smallest movement from high above. They see fine detail at great distance, sense an evolutionary gift that allows them to hunt with silent precision. Meanwhile, nocturnal animals, like owls or cats, have eyes adapted for low light. Their retinas contain a higher proportion of rod cells, sensitive to dimness, and many have a reflective layer behind the retina called the tapetum lucidum, which enhances night vision by bouncing light back through the retina a second time. To them, the nighttime world is not darkness, it is a softened, glowing landscape. Hearing also varies dramatically across species. Bats navigate through echolocation, emitting high-frequency sounds, and listening to the echoes that return. These sounds are far above the range of human hearing, yet to a bat, they create a detailed acoustic map of the world, revealing shape, texture, and distance with every pulse. Dolphins and whales, too, use sonar-like systems, communicating across vast distances with clicks, whistles, and low-frequency songs. These sounds travel through water more efficiently than air, allowing pods to stay in touch, to coordinate movement, to nurture and protect. Some animals hear what we cannot. Elephants, for example, produce and detect infrasound frequencies below the human threshold. These deep rumbles can travel miles through the ground and air, carrying messages of migration, mating, or danger. Standing near a herd, you might hear only silence, while beneath the surface a rich conversation is unfolding. Touch, though often overlooked, is a deeply refined sense in many creatures. The whiskers of a cat or mouse are not simple hairs. They are vibrissae, packed with sensitive nerve endings. They allow the animal to detect air currents, measure openings, and sense the texture of surfaces in total darkness. Octopuses, those quiet wonders of the sea, have thousands of touch receptors along their arms. Each sucker is capable of independent movement and sensation. Touch, for them, is not limited to pressure. It includes chemical cues, taste, and texture. They explore their environment with arms that both feel and think. Taste and smell are especially important for many animals. Dogs, for instance, possess up to 300 million olfactory receptors, compared to about 6 million in humans. Their sense of smell is so acute that they can detect individual components in complex scents, track time through odor trails, and even identify human emotions through subtle chemical changes in sweat. Sharks, swimming silently through salt water, detect blood concentrations as low as 1 part per million, but they also sense electric fields, thanks to specialized organs called the ampullae of Lorenzini, which detect the faint bioelectric signals produced by living bodies. This ability allows them to locate prey even when hidden beneath sand or stone. Some creatures possess senses that humans do not have at all. Migratory birds and sea turtles navigate using magnetoreception, the ability to sense Earth's magnetic field. Though still not fully understood, this internal compass guides them across oceans and continents with unerring accuracy. Pit vipers, like rattlesnakes, perceive infrared radiation through heat-sensitive pits near their eyes. This allows them to see the body heat of warm-blooded prey, even in complete darkness. To them, the world glows with temperature. Electric fish, such as the elephant nose fish of African rivers, generate weak electrical fields and sense disturbances within them. This electrolocation enables them to detect objects, prey, and other fish in murky or dark waters. And among insects, moths, drawn to light and scent, detect pheromones over great distances. A single molecule may trigger a cascade of behavior orientation, flight, courtship. Their world is alive with invisible signals. These extraordinary senses are not only tools of survival, they are expressions of how each creature fits its environment. What seems unimaginable to us is simply natural to them. Their perception, though foreign to our own, is real, complete, and quietly functional. This diversity of sensation reminds us that our experience of the world is partial, not complete. There is much we cannot see, hear, or feel. But this does not diminish our own perception, it simply humbles it. It invites wonder. It reminds us that we live in a layered world, where countless realities unfold in parallel. And in this quiet knowledge, there is peace. To be human is to sense in a particular way, but not the only way. Other beings walk and fly, swim and crawl through dimensions of sound, scent, light, and vibration that we can only imagine. Their presence expands the meaning of life on Earth. So as you lie here, resting in your own gentle field of sensation, know that you are part of something vast. The world is alive with senses, millions of them, humming softly through the night. And you, with your breath, your hearing, your quiet awareness, are one among many, a part of the great sensing fabric of life. Let that thought settle into your stillness. Let it deepen your rest. Let the quiet wonder of other beings rock you gently towards sleep. Part 20. A soothing conclusion. Returning to stillness. And now, we arrive at the edge of this quiet journey through eyes and ears, skin and scent, movement and memory. We have traced the gentle arc of sensation, from the spark of light at the retina to the quiet hush of sound at the eardrum, from the silent pull of balance deep within the inner ear to the warm awareness of one's own breath rising and falling in the dark. We have seen how the senses awaken in the womb, how they shape childhood, how they soften and shift with age. We've walked through the brain's quiet orchestration of perception, where signals become meaning, and meaning becomes memory. We've observed how differences in sensation between individuals, across lifespans, and even between species are not flaws, but expressions of variation. Nature's way of painting the world with many textures, many colors, many ways of knowing. And now, with the senses thoroughly explored, gently understood, and patiently appreciated, we return to stillness. There is something beautiful in this moment, knowing that you do not need to do anything at all. There is no next step, no task, no question to answer, no information to hold. The mind can rest, and the body can soften. The senses are still here, but they are quieter now, like lanterns in the distance, dimmed but not extinguished. Sight fades behind closed eyes. Sound narrows to the rhythm of breath. Touch is reduced to softness, warmth, pressure. Taste and scent may linger faintly, or dissolve entirely into calm neutrality. And beneath them all, interoception continues gently tracking the breath, the heart, the ease of the limbs. The body knows how to relax, it knows how to settle. This is the gift of being human, not only to perceive, but to rest from perception, to retreat, if only briefly, from the flowing world of sound and color and texture, to step inside, where sensation becomes whisper, then stillness. Even here, even now, the nervous system continues its quiet work, maintaining balance, calibrating breath, repairing tissue, releasing thought. You are not empty. You are full of gentle processes, healing, adjusting, releasing. The mind may wander. It may drift toward images, scenes, recollections. That is natural. Let it happen softly. Do not hold. Do not push away. Let thoughts pass through you like wind through tall grass. Notice them if you wish, or let them pass unseen. If you find yourself returning to any part of this journey, a sound remembered, a sensation recalled, a quiet truth about the body or the brain, welcome it. Let it settle beside you. Let it rock you gently, like a familiar rhythm, into deeper ease. There is no need to remain alert. You are safe. The senses are enough. The breath is enough. This moment, just as it is enough. And as you lie here, somewhere between sleep and waking, still and aware, let the world fall away. Let go of the need to think, to name, to grasp. Let the muscles relax. Let the jaw loosen. Let the hands rest softly. Let the feet fall open. Breathe in, and breathe out, and breathe in again. Each breath slower, deeper, quieter. You have listened long and well. You have traveled gently through the world of sensation. Now, let that journey fade. Let silence return. Let the body become heavy. Let the breath become shallow. Let the self dissolve into softness. This is not an ending, only a return to stillness, to calm, to quiet awareness. The senses remain with you, even in sleep. But for now, they rest, and so do you. Good night.